back about, 15 years ago, the very first library that Microsoft introduced for dealing with generic data access was ODBC, which stands for Open Database Connectivity. And this was a function library-based API. What I mean by that is that this was written using a style of programming that, was common at that time. In fact, it's the same way that Windows was written, and that is that you had all these functions that you had to call. And, if you were a C programmer, it was pretty easy to work with. But for the rest of us, it was a little difficult. And so as you'll see, eventually there were different wrappers created around it. But other than the difficulty of working with this function library API interface, it actually was very performant. And ODBC continues to be used quite a bit to this day. It's been actually very, very successful. Not too long after that, Microsoft came out with its first real object-based library for data access, and this was called Data Access Objects, DAO. And DAO was really an object model wrapper around the JET database engine, which was used, of course, for Access at that time, but was also very popular for Visual Basic applications. And JET was a very versatile data engine. It could query many different types of data. And DAO was very successful. I mean, this was really the origin of concepts that have continued to this day, working with record sets and so on. And people continue to use DAO today, especially if they're working with the JET database engine. Well, soon after that, the ODBC programmers started to lust after that nice programming model that they saw in DAO, so we had something called RDO, or Remote Data Objects. DAO allowed you to communicate with server data engines like SQL Server, but you would have to go through the JET engine to get to that ODBC connection to your server database, which was pretty inefficient. So RDO, for Remote Data Objects, provided a direct connection to these remote data engines, hence the name. And yet it used objects that were very similar to DAO. And then to provide this same level of support for working with remote databases for DAO programmers, something was introduced that never really caught on too much, and that was ODBC Direct, which was a DAO extension that was really just kind of a wrapper around RDO using objects that had the same names as the DAO objects. And so this was just an object model wrapper around ODBC. ODBC continued throughout this time to really be the only way to get at server databases like Oracle and SQL Server and DB2 and so on. Whether you were working through DAO or RDO or ODBC Direct, you were ultimately using the function libraries behind the scenes that were part of ODBC. And ODBC was a driver-based model, kind of similar to the model that Microsoft created for printers in Windows around that time, right? Previous to that, each software developer would have to write their own way of connecting to all the different printers in the world, and then Microsoft came up with this idea of a centralized printer driver in Windows, and you could write an application that simply knew how to communicate with the Windows printer manager, and it would take care of communicating with the individual printers, and ODBC worked the same way. Programmers could just program against ODBC, and as long as they had the correct driver to communicate with the data engine that they needed to work with, they didn't have to worry about the particulars of how to communicate with each of those different kinds of databases. The ODBC driver would take care of that, and you would have this way of defining a connection that involves specifying the driver that you wanted to use. You could have what was called a DSN, or you could even use a connect string to specify the driver and the name of the server and so on. And I mention this because a lot of these concepts have survived to this day, and you'll still see them being used even in ADO.NET. The next big change was the introduction of OLEDB and the object model for working with OLEDB from Visual Basic and other higher level languages that was called ADO. And OLEDB was intended to be a generic, universal way of communicating with data, even more universal than ODBC because of the fact that ODBC was specifically geared for working with relational databases. OLEDB was intended to replace ODBC for two reasons. One was that it was object-based, and so it gave a sort of more friendly interface to the data. But the other was that it wasn't limited to relational databases. In fact, it didn't depend on the query processing being performed by the back-end database server. OLEDB supports the idea of having an OLEDB component that actually processes queries. So, for example, there was support for communicating with a mail store, a store of mail messages, and that mail store didn't know anything about queries, and yet once you could connect to the mail store, you could perform SQL queries against your email messages based on their properties and so on. ADO, which was the object model that was used by most programmers working with OLEDB, unless they were C programmers working directly against the core OLEDB interfaces, ADO was similar in the objects that it worked with to the things that came before, so it was familiar. And there was one really important innovation in ADO, something that ended up being more and more important as time went on, and something that really formed the basis for the motivation in developing ADO.NET, and that is ADO introduced the idea of client-side cursors. And it's actually, the cursor engine in ADO is actually something that was taken from FoxPro. Microsoft had acquired FoxPro, and one of the goodies that they got from FoxPro was this client-side cursor engine that ADO made use of. And when we say client-side cursors, what we mean is the ability to disconnect from a database, to drop a connection, and still have a cached set of data, a tabular set of data, sort of organized like the tables in a database with rows and columns that you could navigate in and make changes to in this disconnected state. And then when you were ready, you could reconnect to the database and push your changes back to the database. This was really innovative, and this was coming just at the beginning when people were starting to want to go beyond the client-server model and create n-tiered models where there would be business objects in a middle tier, and you needed some way of moving data back and forth from those business objects. But the problem with these ADO record sets that could be disconnected from data is that they were still very tied in with Windows. They were COM-based. It required COM marshalling to move the data around, so it didn't really lend itself to moving data across an internet connection, for example, and the internet was starting to become more and more important to business applications. You were really kind of tied into Windows-based applications. You couldn't work with other platforms. People were starting to think about wanting to use XML in order to remote their data rather than relying on these proprietary ADO record sets. And that really was the motivation for developing a completely new model in ADO.NET. ADO.NET is very XML friendly. It's very easy to create a disconnected cache of data, to then generate XML, an XML representation of that data, and then you can send that data to any platform across any connection because XML is HTTP friendly, right? In other words, the HTTP protocol that's used on the internet is used for sending text around, and since XML is simply text with the right kinds of tags, XML flows across HTTP very freely. And, this is all very familiar and kind of taken for granted by us today, but this was really kind of cutting-edge technology when ADO was first being developed. In ADO.NET, there's a much clearer separation than we had in the previous ADO object model between the connected and disconnected data objects. In fact, in ADO, many people never even realized that there were these client-side cursors that you could create. They would just open record sets, and they would be connected to the database continuously. And even if they did disconnect, it was subtle differences where you were using the same objects, but maybe certain properties would be set differently. In ADO.NET, as you'll see, there's completely separate objects that are used when you're disconnected working with data from the objects that you use to connect and to retrieve data or push data changes back to the database. Also, ADO.NET has much better support for working with stored procedures, which became, really important to people. It was a shortcoming in ADO. If you had an ADO, a classic ADO record set, and you made changes to the data in the client-side cursor record set, right? And then you wanted to push those changes back, well, ADO behind the scenes would automatically generate these update, insert, and delete statements and then try and execute them on the server. And a lot of people didn't like that. They wanted more control over the SQL statements that got executed, or in many cases, they wanted those SQL statements to be encapsulated within stored procedures. And if you wanted to run stored procedures, then it took a lot of programming. You had to walk through every row yourself, and you had to then extract the values and feed them into the parameters of your stored procedures. As you'll see, ADO.NET does all that for you automatically. In ADO.NET, there's a new object called a data adapter that can walk through all of the rows in a data table that you're working with locally, and it'll detect whether it's a new row and therefore needs an insert command, or if it's a updated row that needs an update command. And you can specify that for this insert and update command you want to use this stored procedure or that stored procedure, and you can create bindings between the columns in your ADO.NET data table and the parameters in those stored procedures. And in this way, very automatically, without having to write a lot of code, just by setting a few properties, you can make use of stored procedures to implement the changes that you want to push back to the database.